Hi everyone. Good afternoon. We are back into our session, and this is going to be lecture number 5 on network theory. So I think many of you might have enjoyed. At least 100 student or aspirant, you can say, might have enjoyed my gate crash course. Okay, so I'm not targeting a million of people. They are going to enjoy this course. People who are reaching to my gate crash course, they will be happily satisfied. Okay, that is what my promise is going to be, right? So can you confirm my voice is audible or not, so that we can start the session here? And this is going to be lecture number 5, and as we are doing some sort of a revision, right? So we are going to do some sort of a revision only. Okay, and from the 1st of December, right, from the 1st of December, we are going to start uh, we are going to start what? The PYQ. Okay, the PYQ will be discussed, right? So yes, so this is going to be lecture number 5. Okay, on network theory. So you have to learn new insight, how to solve question, by inspection. As you might have seen me in various groups, right? I always solve the question just by looking at the question. Okay, by inspection. So you should also develop this kind of habit, right? So yeah, so please join the session quickly so that and let me confirm whether the voice is okay or not, because nobody is there right now. Yes, just I'm confirming. Right. You should also. Yeah, it is fine. The voice and everything is okay. So let us start the session here, guys. So today, from today onwards, I'm going to talk about, you can say, the basic concepts, right? Like we will start the circuit analysis, right? And this is one of the very important lecture, you can say. I'm going to talk about circuit analysis. Okay, how to analyze the circuit, that is very important to keep in mind, right? Because till now we have discussed about power, energy, many concepts I have discussed, right? And I also claim that if one of the only one source is present in the network, right, in entire network, so that source has to deliver power, right? That source has to deliver power. It will not you can say absorb power, right? So that you have to keep in mind. But if there are many independent sources, so one of the source can absorb power, one of the source can. And I have shown you the when they are said to be active element, when they are said to be passive element. Okay, using some coordinate systems, right? Like first quadrant, second quadrant, third quadrant, right? Okay, so in circuit analysis, basically we are going to have suppose any circuit you take, there might be n number of nodes. Okay, suppose any circuit is there, right? Circuit you can say that with capital N number of nodes, okay, and capital B number of branches. Okay, capital N number of nodes and capital B number of branches. Okay, understood. So if two terminal device you have, or you can say two terminal element, so that is going to be a branch, right? Any two terminal element is going to be a branch. Okay, that you have to always keep in mind. Understand? So while solving the circuit, while analyzing circuit, how many equations you are going to get, okay, while solving the circuit, right? That is very important to keep in mind, right? So let me take one circuit and let us try to identify how many nodes are there and how many branches are there. And depending upon that, we can talk about circuit analysis. So there will be two kind of method that we are going to use to solve the circuit. One will be nodal analysis, okay, node method you can say, and one will be the mesh analysis, right? So we'll see that, and where we have to use what. Okay, that is also one confusion, many student have lot of confusion that कि कहाँ पर हमें circuit मतलब कहाँ पर node लगाना चाहिए, कहाँ पर mesh लगाना चाहिए. It depends upon you, or totally it depends on you, right? So yeah, so if I take one question here, suppose you see here, this is this, you can say this is going to be a circuit. Okay, a very simple circuit I'm just going to take, and yeah, you can say this is going to be a circuit, right? See, you can make one, you can put one wire here or just put one node here, that's it. Okay, fine. So this is going to be one more resistor you can connect here, and Now you can connect one current source here. This is going to be a current source, okay, and one more current source you can connect here. Now if I ask you how many number of nodes are there in this circuit, number of nodes, so you should be able to identify how many nodes are there, right? One node is going to be this, one node is this, second node, third node is this, and the fourth node is this. So there are four nodes, you can say. There are four nodes, right? There are four nodes. So if somebody is going to ask how many nodes are there, so first of all you have to decide how many nodes are there. So four nodes are there, right? And the analysis which we are going to decide, okay, nodal analysis we are going to use or mesh analysis, depends upon that analysis should need at minimum, I mean, there should not be many equations to solve. Otherwise, if there are many equations to solve, then life will be very tough, right? In the gate examination. So you have to use that method which has to, which will force you to solve only one or two equations, right? That's it, okay? Otherwise, solving equation, there are many equations, then you have to go for linear algebra and all, right? That takes a lot of time, right? But in the gate examination, very simple questions will be asked, right? Don't worry. So now, can you tell me how many branches are there? So yes, as I told you that the definition of branch is simple. What is the definition of branch? The element itself is a branch. Element itself is a branch. Okay, is a branch. That you have to understand always. Any element is there, a two terminal device, that is the branch only, right? So how many elements are there? Just you have to count. 1 2 3 4 5 6 7 8. So branches are kitne hain? How many branches are there? There are 8 branches. Okay, so I think this is clear for all, right? So how to count number of branches? Just count the number of element in the circuit or a network, you can say, right? So there are 4 nodes and there are 8 branches, right? That is what the very important thing that you have to keep in mind. If there are, you can say, B branches, okay, if there are B branches, so how many independent equation you need? You will be, see, you can compute voltage. You can say if there are B branches means you can compute B voltage and B current, right? Yeah. Suppose B number of branches are there. Okay, B number of branches. Branches are, what is the branch basically? Branches is nothing but two terminal element. Simple. Two terminal element. Simply consider two terminal element, that is going to be a branch. That is very important to understand, okay? So if there are B branches, तो आप कितने voltage compute कर सकते हो? You can compute B number of voltage, right? So B voltages, I mean across each element there can be a voltage, right? So across each element there will be a voltage, you can say B voltage, okay? B voltages, okay? And you can say that, and B currents, okay? Through each element there will be a current as well. Understand? So how many, you can say how many variables to solve for them? There will be two B variables, right? B number of, you can say, voltage, and B number of, total number of variables that you have to solve is, you can say that 2B. So how many equations you need? 2B equations you need, right? 2B equations, okay? 2 times the branch. Okay, okay, that is very important to keep in mind. So 2B independent equations required. 2B independent equations are required. Okay, I hope this makes sense to you, right? So if I talk about KCL, right? If I talk about KCL, so KCL we have to apply at every node, right? And KVL around every loop, okay? So KCL we have to apply where? KCL at the rate, you can say every node. We can apply KCL at every node, okay, provided the current should be known, right? If you know the current, then you can apply the KCL, and KVL can be applied around every loop, right? Okay, so you can always find the VI characteristic, right, using these KCL and KVL for every loop, you can say that around every loop. Okay, so that you can characterize what you can talk about VI relationship for each element. Using this, you can talk about VI relationship, okay, for every element, okay, for every element. Understood? So in this, while talking about circuit, right, when you do circuit analysis, so you are trying to figure it out what the VI relationship for every element. In that process, you have to apply KCL or KVL, right? Okay, so KCL is always preferred to be applied at every node, and you have to always keep in mind there will be one reference, right? One reference is very important while applying the KCL at any node, right? Because the voltage has to be measured with respect to certain reference. Okay, that is very, very important to keep in mind. Now the question is number of equations, how many number of KCL equation you need, okay, and how many number of, you can say, number of independent KCL equation you need. Suppose you are going to apply KCL at every node, how many KCL equations you need, and how many mesh equation in future you need, right? That is what we have to keep in mind. Understood? Okay, so it is very, very important to keep in mind. So suppose there are n number of nodes, right? Suppose there are n number of nodes, okay? N nodes are there in the circuit. So n minus 1 independent KCL equations, okay, will be there to solve the circuit, okay, n minus 1 independent KCL equation. Okay, this kind of questions are asked also, right? Okay, suppose n number of nodes are there, so how many independent KCL equations are needed to solve the circuit? So that will be n minus 1. Okay, that is going to be n minus 1. That is very important. N minus 1 KCL equations, right? Please remember that. Yes. And number of independent KVL equations, okay? Number of independent KVL equations, okay? So let me talk about that also. So number of independent KVL equations, right, in any circuit. Okay, so you have to decide always now, okay, based on this, like, how many KCL equations are required to solve the circuit, how many KVL equations are required to analyze the circuit. So if suppose there are many loops, right, suppose there are n number of nodes, okay, if there are n number of nodes, you can say n number of nodes and b number of branches, right? Okay, so 1 KVL you're going to apply for every loop, right? Okay, you have to decide how many loops are there, or you can say how many mesh is there, right? Okay, understood? So any circuit will be there. Okay, so though I'm not going to get into graph theory and all, like I'm not going to talk about what is the meaning of trees and all, right? All those things are not in our syllabus, so I will not discuss, though that is also important, okay, as far as you want to become a circuit designer in future. So you should have the knowledge about graph theory as well. What is the meaning of tree? So tree is just, I'm going to define here, the tree is nothing but, you can say, the set of branches, okay, uh okay, and tree is going to be what? It will always form a loop, okay? In any circuit, if there is a loop, okay, that is called a tree. Understood? Sorry, I think this is this this uh, this definition is wrong, right? Let me correct again. देखो tree का मतलब क्या हो जाएगा? Tree. Suppose let me take one. There should not be a circuit then, right? There should not be any closed loop. Okay, that is not. If there is a closed loop, means that is not going to be a tree. That you have to keep in mind, right? So set of branches. Tree is what? Let me write the definition here. Tree. Set of branches. Okay. Tree is nothing but a set of branches. Okay. You can say that suppose there are b number of branches in the circuit. So it can be the subset of b branches, right? Set of branches means what? Subset of b branches. Okay. Understood? Please remember, if there is a loop, that is not called as a tree, okay, in the circuit. Please remember that. Okay, I gave some like I by mistake I used that a word. Okay, so remember, set of branches, subset of B branch. Okay, subset of B branch you can say. Okay, traversing all nodes. Okay? That should touch all nodes. You can say traversing all nodes. Okay, traversing all nodes without forming a loop. Without forming a loop, right? Okay, so these are the basic requirement for tree to be called as, right? So n minus 1 branches will be there. Okay, in suppose there are n number of nodes, so n minus 1 branches in n nodes circuit you can say, right? So there will be n number of nodes, okay, and n minus 1 branches are going to be used, right? So suppose there are you can say for the tree you can say, right? So 3 branches are going to form a tree. Okay, suppose there are n number of nodes, so n minus 1 branches are going to form a tree. Okay, fine. So let me talk here as suppose circuit is having n number of nodes, circuit with n nodes and B branches, right? So number one point you can say here is that n minus 1 branches in the tree. So how many branches will be there in the tree? You can say that n minus 1 branches will be in the tree, right? Right. And the second point that you have to remember is if you subtract these many n minus 1 number of branches in the tree, right? Okay, so from the total, so total branch is B and just subtract this n minus 1. Okay, so these remaining branches are known as co-tree. Remaining branches are known as co-tree. Co-tree. Okay, if you resolve this, so it will be B minus n plus 1. So I think many of you might be familiar with this formula. Suppose there are B number of branches, there are n number of nodes in the circuit, so you can find out the number of mesh equation, right? And this is the equation we use. And from where we got this equation, you can see here, right? We have got a circuit, we draw the graph, we can draw the graph and we can find the number of tree, okay, in the graph. Okay, how many branches will be required to form a tree? 3 branches. Suppose there are 4 nodes, 3 branches are needed to form a tree. Okay, and how many co-trees will be there? How can you find out? Just subtract from the total number of branches minus the n minus 1 branches which is forming a tree, right? That will give you the co-tree. So keep in mind that this is nothing but the number of KVL equations, okay, in any circuit. So suppose there are n number of nodes. So how many KCL equation you need? N minus 1 KCL equation, right? And there are B branches you can say in the circuit I'm saying. So how many KVL equation you need? B minus n plus 1 KVL equations, right? So you can decide now, okay, whenever circuit will be given, okay, and you can see whether you have to write many KCL equations or KVL equations, right? Many people, what they do is in analog circuit, they go for network theory. I mean, they purely think that analog circuit is completely network theory. Let me tell you guys, we are going to use the circuit equipments, like, you know, how to solve the circuit, right? We are going to use all the concept, whatever we have been learning in the circuit theory, but we don't have to lose the flavor of analog, right? You have to keep in mind uh, the approximation. You have to keep in mind what is analog and what we are doing in an analog circuit, right? Don't get lost into circuit analysis only, right? That is what my suggestion will be. I have seen many people do. Okay, fine. So from where we started, suppose there are n nodes and B branches in the circuit. Okay, n nodes and B branches in the circuit. So how many equations we need? 2B equations we need, right? Okay, 2B equations. Okay, so if I talk about KCL equation, कितने रहेंगे? तो n minus 1 KCL equations. Okay, And the KVL equation, how many? So you can say that B minus N plus 1. So if you try to add these two, okay, so you will get the B number of equations you're going to get, okay, B number of equations, okay. If you combine KCL plus KVL equations, so they will give you B number of equations, okay. And branch and IV relationship will give you B number of equations, right? So 2B equations can solve for 2B variables, okay, like B number of currents and B number of voltages, okay. Fine. So let me take a very simple circuit and try to solve here. And let me see what you're going to do. Suppose we have got a single independent source in the circuit, right? So I'm going to start a circuit analysis with the single independent source. Right? Single independent source. So suppose in the question they have given single independent source, right? And they can connect the resistance, okay? So just I'm going to consider here single independent source. You can say this is going to be a voltage source V, and there is a resistance R, right? There is a resistance R, okay? You can say R1. You can say R1, yeah, no problem. Now they are asking what? Can you find the voltage and the current, okay? All those things, right? In this circuit, can you find the voltage? You will say that yes, we can find the voltage across this resistance. So the voltage across this resistance is going to be V only, right? Because they are connected in parallel. Now you can find the current also. So current is gonna be V by R1, right? This current you can find out always. Okay, this is the current which is flowing, right? So this is the, you can say this is going to be a loop. One loop is there, right? So you can apply the K. You can say you can also apply the KVL right here. Okay, one loop is there. So how many equation you are going to get, right? Okay, in case of loop or okay, here you don't have to apply the KCL or KVL, because since there is a single independent source, okay, and you can quickly find out the current, and this current is going to be rotating here, right? Current will be here, the current is going to be like this, V by R1, and the current will be, you know, moving like this, okay? Please remember that. Understood. So let me connect one more resistance then, right? Suppose I'm just going to connect one more resistance here, single source only, right? But now I'm just going to increase the number of resistance, and these resistances are connected in series, you can say R1 and R2, right? Now there is a voltage V. Now you can't say that this V is going to be across R1 or across R2, right? Now this voltage is going to be divided across this. Okay, so you have to always keep in mind this. Okay, you can say in this manner, or you can combine them and you can make this circuit like this thing. You can convert this circuit as single independent source circuit. Okay, you see this is nothing but R1 plus R2, and this is V. Now we can find out the current. Current is going to be equal to what? V by R1 plus R2. So there is only one equation that you need to find the current. I equal to V by R1 plus R2, right? Or you can also find the individual voltage across this element, right? You can find the individual voltage across this element just by using voltage division rule, right? I have discussed this rule, okay? So you can find V1, you can find V2, right? So V1 can be found out, whatever current is flowing, you see what current is flowing through this? Current is flowing through this is V by R1 plus R2, right? So what is the drop across this? Drop across this is going to be I times R1, which is nothing but V by R1 plus R2 times R1, right? And V2 is equal to I times R2, which is nothing but V by R1 plus R2 times R2, right? So you see, these are what? The voltage division formulas, right? Voltage division rule we are using. Okay, so instead of finding the current directly, you can find out the voltage across each resistance if you know the total voltage. Okay? And you have to keep in mind, suppose this is plus to minus, so it's okay. The voltage across this R1 and R2 is going to be positive. Suppose if you reverse the voltage, right? Like if you make minus and plus, so the voltage across this will be negative, right? So these are the concepts that you have to remember. So single independent source circuit, most of the time single independent source circuit is asked, right? मतलब आपको क्वेश्चन दिया रहेगा, आपको ये देखना कितने इंडिपेंडेंट सोर्स लगे हैं एंड कैसे सॉल्व करना है, राइट? सो ये बहुत ही सिंपल है, right? We are not using here any sort of KVL or KCL kind of thing, right? Why to use KVL and KCL if there is single source? Okay, that you have to always decide. In analog circuit, these rules are very useful, right? If जब single source है, so directly you can use voltage divider formula, or you know, I hope this makes sense, right? So you can directly find out, just you move around this, right? And you can find out the current here, right? That is V by R1. And this current will circulate in the loop. Okay, this current is going to be circulate in the loop, okay? So I think this is clear. Now let us consider the single independent current source. Okay? Single independent current source, okay? So whenever single voltage source is there, so you can use voltage division rule, okay, if resistances are connected in series. But now let us talk about single current source. Suppose this is a current source I, and this is going to be a resistance. Okay, this is R1 and this is R2, right? So here in this case, what you can do here is you don't have to apply again KCL and KVL. Many students, what they do is whenever this kind of a situation occurs, still they apply KCL and KVL and they waste their time, right? So whenever single source is present, single independent source is present, so I think you don't need to apply KVL or KCL kind of thing. Yeah. So yes, I believe 1 minute, guys. Some setting issue occurs. Yeah, now we are back. Okay. So please remember these concepts. These concepts are very, very important to keep in mind. Okay. Fine. So R1 and R2 is there, right? R1 and R2 is there. This is very, very important to keep in mind. So now what you can do, you can directly find out the current, through R1 and R2. You don't have to apply KCL and KVL. Many students do, right? But here, why to apply KCL and KVL, right? Since you know that you can find out the voltage across R1 and R2. So how can you find the voltage across R1 and R2? You need to find the current, right, through this. This is I1 and this is I2. So I1 is nothing but total current, I, opposite resistance upon sum of the resistance, you can say R1 plus R2. Okay, and I2 is going to be what? I2 will be nothing but, I times R1 by R1 plus R2, right? So this is obtained just by using current division rule. Current division rule. Okay, so please use these techniques in analog circuit. Okay, while solving the analog circuit problem. Okay, so now you can find out the voltage across this, right? The voltage across this, if you always take the some reference here, so here V1, here V2, the voltage is going to be what? Since they are connected in parallel, so the voltage is going to be same, right? Remember that the voltage is going to be same. V1 and V2 should be same here, right? V1 should be equal to V2, and you can check also, right? Okay, this V1 and V2 should be equal to V only. Understood? You can take the voltage at this point V. Okay. So this is how we apply, and you can also consider these R1 and R2, like you can take the reciprocal of R1 and R2, right? And you can say that that is going to be conductance and all, right? So it is very simple to analyze. Now, how to complicate the circuit? See, now I'm just going to complicate the circuit. See, single source problem. This is voltage. Now I'm just going to connect this resistance and then again one more resistance like this. But this circuit is what? Single source circuit only, right? Okay, so this circuit is single source circuit. So why to, you can find out the current through each branch. Okay, you can find out the voltage across each. So R1 and R2 and R3. Right? Suppose someone is going to ask you, what is the current through, this R2, right? What are the current through these R1 and R2? R2 and R3, right? So you can easily find out, right? Since you know that the current is going to be same. Single loop is there, no? Current will be same. So this current I is going to be flowing through this. So this current you can say I times R3 by R2 plus R3, and this current is going to be I times, no, but this current, if I1 is flowing through this, you can say same current flow will flow here, right? To add these two currents. Okay, I hope this makes sense. So this is very simple circuit analysis. Okay, you should never feel any sort of doubt. Okay, while looking at this kind of a circuit, small circuits. Because in GATE 2013, 14, 15, if you look at the question, just look at previous year question, आपको कभी कोई डाउट नहीं आने वाला है, ठीक है? आप okay, you will never face any sort of doubt, you will be able to solve the question, ठीक है? बस आप क्वेश्चन देखो, आपका रिएक्शन स्टार्ट हो जाना चाहिए, राइट? द रिएक्शन पॉइंट इज दिस कि अच्छा, ओके, सिंगल सोर्स इज प्रेजेंट, ओके, सो यू कैन, और व्हाट यू कैन डू, यू कैन क्विकली फाइंड आउट लाइक दिस. ये एक तरीका है, मैंने आपको बता दिया, ठीक है? एक तरीका क्या हो सकता है कि I टाइम्स R2 by R2 plus R3. नाउ वन मोर तरीका यू कैन से कि यू जस्ट सॉल्व दिस, राइट? तो सॉल्व करोगे क्या आ जाएगा, प्लस माइनस V, and this is R1, and this is nothing but R2 R3 by R2 plus R3, and now you see the current is flowing same in this loop, the current is gonna be same, ठीक है? एक तरीका और हो सकता है, one more way is there. What is that way? You can combine all the resistance and then find out this current I. So you can combine all the voltages, right? Okay, I mean all the current. So to find current here, so you just combine this, right? And then you can take V by the combination, you can say R equivalent is going to be I. So this is how circuit analysis is done, okay, based on if there is a single based on single okay, so this is very, very important to keep in mind, understand? Fine, so please remember this, this is very, very important to keep in mind. Okay, so let me go ahead and talk about few more concepts. So this is one way, like if one independent source is connected, then you can talk about, right? Okay, so this is going to work with all the circuits, right? Like which, suppose we have got single dependent source in the circuit, single dependent source you can say, right? This same concept you are going to use, right? You can use voltage divider, you can use current division, right? So, but don't think that, oh, we are going to use KCL, KVL again, right? Why you are wasting your time if there is a single source, okay, in the circuit, okay? So why you are using KVL, KCLs, okay, to waste your time, right? So don't use that, okay? Always go for KCL. I mean, you might have seen whenever I solve the question, right? So I always try to use, voltage division, current division. इतने अच्छे rules दिए हैं, just use them and optimize your process solving, okay? Process of solving. Why you are applying KVL, KCLs, wasting time, right? But yeah, if you are in doubt, you have to use KCL, KVLs. Okay, that is very important to keep in mind, right? So now they can give you one independent source and they can give you any sort of, you can say any sort of a very complicated resistive network, right? So you have to solve that resistive network, right? So things can get messy if you have, let's say, like this, like so many resistances are connected, right? Okay, and a big circuit resistor is, okay, connected, okay, and then current source is there, okay. So you need a very systematic approach, okay, in that process, because single, okay, that is very simple, you can use voltage division, current division rule. But मान लो ऐसा situation है कि suppose one current source is there and now there are resistance, okay, you can say that this kind of a situation, तो आपको फिर सर्किट एनालिसिस की जरूरत पड़ेगी प्रॉपरली. एक सिस्टमैटिक अप्रोच इज वेरी इंपॉर्टेंट, राइट? तो दिस काइंड ऑफ सिचुएशन इज देयर. बहुत ही कॉम्प्लिकेटेड सर्किट है, कैसे understood. So this is the situation that you can think here, right? Now they have connected something from here, okay, from here to here, okay. Now please remember these points, okay, and now they have connected something from here to okay, like this kind of a circuit. Okay, so if you look from here, it is a single source circuit only, right? But there is a messy network, okay, connected to you. There is a messy network connected to you. Understand? So please remember that. Okay, so please keep going. Okay, like this. Yes. So I think this is clear for all, right? So याद रखना कि now we need some systematic approach, right? So some systematic approach to okay. So when there are many, you can say many independent sources are there, right? So how do we analyze the circuit? That is very important to keep in mind. So analysis of circuit, you can say, right? Suppose there are many independent sources connected in the network. Okay? Analysis of circuit with multiple independent sources using what? The very important concept we are going to use is superposition, right? So what we will do here is suppose there are many voltages or many current source. This happens in network in analog circuit also. कि आप लोग क्या करते हो कि if there are many independent sources, right? So what we do always is uh, okay, we always you know deactivate one of the voltage source or current source, and then we find out the response, right? And then we deactivate that one again, we find, okay, so in that process at the end of the day what we do is we combine them, right? We can superimpose, we can add all the output, or we can add all the response which you have calculated individually, right? Okay. So where we are going to use this superposition, right? So using superposition to solve circuit with more than one independent sources, right? Okay, that is very, very important to keep in mind. So the circuit should be what? Linear circuit, first of all. If the circuit is linear, right? Linear circuit, or you can say linear element, okay, where we can use superposition, that is also very important to keep in mind. So suppose this is a black box and there are many independent sources. Suppose this is going to be a many independent sources, right? Okay. So this is going to be a resistance, okay, and this is going to be you can say one capacitor here, right? These are all linear elements. So this black box should contain always some sort of a linear element in it, okay? There should not be non-linear element, otherwise you cannot apply superposition, right? So this is the linear element, okay? And suppose there are dependent sources also, okay? Sometimes many students have a lot of confusion. If there is a dependent source, then the circuit becomes non-linear. No, it is a linear circuit only, okay? So linear circuit, keep in mind, linear circuit, okay, with you can say linear element, with linear elements and independent sources. Okay. So here the independent sources are there, but inside this black box there can be any kind of element which are linear in nature, right? So controlling quantity within the circuit, okay, is going to be also a linear element only. So in this circuit you see there are this is one voltage source, there is one current source, right? And suppose there is one more current source here. In this situation, what you have to go for, you have to use superposition, and superposition plays an important role in circuit analysis. Superposition comes into picture, right? So in fact I always use superposition. I always encourage people to go for Thevenin theorem, use Thevenin, okay, use Norton, use superposition, okay, use voltage division, voltage current division, okay. All these concepts you have to use, okay, to become a smart guy, okay. So if you're solving any question, so you can always do, right? So what is the meaning of superposition? That you have to understand. The meaning of superposition is nothing but effect of multiple independent sources acting together, okay. Effect of multiple independent sources acting together is going to be equal to what? The sum of effects with each independent sources acting one at a time, right? मतलब क्या हो जाएगा? Suppose one of the independent source is acting at a time, right? You try to find the effect, you try to find the response, okay. Second independent source is acting at a time, you find out the response, okay. Then you add them, that is called superposition. That's it. Okay, so I'm not going to write the definition here, you can understand, right? So what you can do here is, when there is a voltage source, you know, if there is an independent voltage source or independent current source, you try to sort that. Suppose you want to find you want to solve this network, okay. So suppose this guy is active, right? This guy is active. You can open them, right? O dot C, and you can O dot C, right? And you can find the response because of this voltage source, okay. And then you deactivate this voltage source and then try to find because of this current source, you can open it, right? So voltage sources are short circuited, remember, and current sources are open circuited. I'm talking about independent current source or independent voltage source, right? So you have to replace it, okay, in order to deactivate them, right? So if suppose only one of the voltage source is acting, so other current source has to be open. Understood? So that is very, very important to keep in mind. Then overall response you can add. Right? That is what the technique that you can always go for. And whatever response you are adding, they should have the same units. ऐसा नहीं है कि मान लो you have found out the current because of current source, you have found out the voltage because of voltage source, and then if you are finding the voltage across any resistance, so find out the voltage across that resistance because of independent voltage source, independent current source, okay, and then add them. Okay. Fine. So suppose let me take one circuit here and try to explain you a very small circuit, and you can use the superposition, right? So superposition is nothing but, you know, when there are many independent sources and there are linear elements. Yeah, you see R1 and R2, right? R1 and R2, and this is going to be your, okay, this is going to be I3 here, right? This is R2. Understood? So this is going to be, please remember this is going to be I2 here, right? So there are, how many sources are there? And there is only linear element, you see. If you try to enclose them in some black box here, so R1 and R2, they are linear, and outside you see these are the sources which are connected in this circuit, okay. Now you can, how can you find out the, suppose somebody is asking that somebody is asking what is the current through R2, okay. That people can ask what is the current through R2, right? So you have to find the current through all the all the sources acting at a time. Suppose someone is going to ask you what is this Ix, you can find Ix. So what you can do here is you can just open these guys, you just open them. So Ix will be equal to Ix, because of this V1, you can say, is going to be V1 by, you know, R1 plus R2. That is first. Now you just forget about this voltage source. Okay, just forget about this voltage source by short circuit. Okay, so you can write by superposition, you can write this Ix in one line. So I'm just writing this is because of V1 acting V1. Okay, and I2 and I3 are okay. Now let us consider this. You can say that this I2, and let me open this and this, right? Okay. Now what will happen is that Ix you want to find, so this will be equal to what? So it is going to be I2, okay, I2 times R1 by R1 plus R2, right? Okay, you can use the current division rule and simply you can write this. Because since it will be sorted, so R1 and R2 will be in parallel and there is only one current source. So you can use the current division rule. Now, since it is sorted, it is open and this current is going outside. Okay, like it is not entering to this circuit. So you can say that minus I3 times R1 by R1 plus R2. Right? You see, I'm not using any sort of KCL or KVL, but I'm using just, okay, superposition, right? So there is no chance of violating any law. Understood? In one line, you can find the current here. This in this manner, if you are having this kind of command, then only you will get below 10 rank, below 5 rank, you will get into ISC and IIT. Otherwise, if you think that solving question in very lengthy manner, that takes you a lot of time. That's it. Okay, that is going to waste your time. That's so understand from me what the सर्किट एनालिसिस कैसे सॉल्व करते हैं. अब देखो ये सर्किट था, Ix निकालना था. I wrote this equation in one line, right? I solved this question in one line, right? So you have to think here. V1 is acting, in this case I2 is acting, in this case I1 is acting, I3, other guys are just deactivated. Okay, I'm not going to show it separately, right? You should be in a position to write the answer in one line, right? Okay, so the next concept that we are going to prefer, if the like as the circuit becomes more complicated, so we go for nodal analysis, right? तो आपको नोडल एनालिसिस याद रखना है. नोडल एनालिसिस, सिस्टमैटिक अप्रोच, सिस्टमैटिक वे से अगर सॉल्व करना है, if there are n number of nodes and b number of branches, okay, n number of nodes, b number of branches, n number of nodes and b number of branches, then n minus 1 KCL equations, n minus 1 KCL equations, n minus 1 KCL equations, okay, and b minus n plus 1, right, KVL equations, you can say, right? Okay. So in the exam question will be asked also, right, ki how many KVL equation you can write. Suppose there are n number of nodes and b number of branches, so you should know these formulas, okay, and how many element relationship you can find. You can find b number of jitne branch utne element relationship you can find. Relationship between voltage and current, okay, IV relationship, okay. For that you have to use Ohm's law, okay. And while applying the nodal analysis, what you have to do? What is the first step that you have to do always? Nodal analysis में क्या करते हैं? कोई भी question आएगा, if you want to apply the nodal analysis, you are going to start with the KCL equations, right? First step is going to be start with KCL equations. Okay, start with KCL equations, right? And there will be where we have to apply KCL equation. That is also very important to keep in mind. I'm talking about electrical circuit, guys. So how many KCL equations has to be written? Okay, so there will be n number of nodes. You can always write n minus 1 equations you can write. Okay, at the rate, you can say that n minus 1 nodes of the circuit. Okay, so while starting the nodal analysis, you have to apply what? You have to apply KCL. The very first point is KCL you apply. Okay, KCL आप लगा दो direct, and then once you have applied the KCL means what? You should know the current. Okay, you should know the current. Let me just show you the circuit. Simple circuit I'm just going to show you. Suppose this is a circuit. This is going to be a circuit, you can say. Okay. And there are current source, you can say these are the current source, and there is a current source, one more current source, right? Okay, this kind of a circuit is given, suppose, right? And then so you can apply the KCL at any node, right? So you can take this node, you can take this node, you can take this node, right? And apply. This is first node, second node, and third node. And there, this is also a node only, guys. Okay, so there are 4 nodes in the circuit, but how many equations you can write? 3 equations, right? Okay, n minus 1. Now you should know this current, you should know this current is, you can consider the current by yourself, right? Okay, and एक और important point है, what? All the node voltages you have to consider. Okay, you have to write all the voltage node with respect to a ground. Okay, the reference node is going to be a ground here, guys. This is going to be a reference node. Okay, so whenever you are writing V1 here, so you should always consider one reference, right? Don't forget that. Many students always forget this. Okay, so voltage across this V1, it means the voltage at this point is higher compared to this point, right? So reference voltage should be there, and then you can apply the KCL equation. I mean, you can write the KCL at that node, right? Fine. KCL followed by that current, right? So current can be expressed in terms of voltage and resistance. You will be applying Ohm's law over there, right? So KCL plus Ohm's law is going to be the nodal. So we call it nodal analysis, right? Okay. So please remember, I'm not going to solve, random circuit I took. Okay, so you can always write this. Okay. And you can get some sort of, suppose there are 3 nodes, means 3 equations you will get. Sorry, 4 nodes are there, 3 equations you will get. So you're not able to solve using some calculator, right? Nowadays online calculator is there. So you can go for linear algebra, right? You know how to solve system of linear equations. Okay, so you can solve it using elimination methods, or you can use the Cramer's rule and all. So I will suggest just to go for system of linear equation. कैसे solve करते हैं? You can solve that, okay, using elimination method as well as back substitution method. Okay, if there are 3 equations, okay, sometimes in your exam they will give you the circuit and they will simply give you the matrix. One of the matrix they will give you, so you have to just write the equation, that's it. Okay, you don't have to solve that equation. So nowadays in the gate exam they just ask you to write the equations. Okay, that's it. Understood? So these are the things that I wanted to talk about. Okay, I'm not gonna be going, I'm not going to get into more detail here. Okay, fine. So you can have the conductance matrix also. You can just just write the nodal analysis and you can get the conductance matrix, right? Fine. So in nodal analysis, basically you have to just apply the KCL, right? And then you can find the node voltages and all, right? Okay. And how to get the node voltage and all, you need to know the IV relationship across each terminal, across each element, right? अक्रॉस ईच एलिमेंट आपके पास क्या होना चाहिए, मतलब आपको पता होना चाहिए, ठीक है, कि क्या आईवी रिलेशनशिप है। Fine. मैं तो डायरेक्ट बता सकता हूँ, आप यू नो मतलब जैसे मान लो एक सर्किट मैं लेता हूँ, सिंपल सा सर्किट, देखो कितना फास्ट तरीके से करेंगे। अ, मान लो एक नेट करंट सोर्स यहाँ पर दिया हुआ है, एंड देयर इज अ रजिस्टर 2K, ओके, एंड दिस इज गोइंग टू बी 4K, ओके, दिस इज 1K। तो जब भी आपको यहाँ पर करंट सोर्सेज प्रेजेंट है यहाँ, राइट, ऑल गाइज आर करंट सोर्स हियर, so this is current source, this is 14 मिली एम्पियर, एंड ये वाला करंट सोर्स जो है तो यू कैन से दैट इट इज 7 मिली एम्पियर, ठीक है। अब यहाँ पर क्या करना है, यू हैव टू जस्ट यू इफ यू वांट टू फाइंड द वोल्टेज नोड एंड ऑल, देयर आर 3 नोड्स। एक तो नोड रेफरेंस वाला हो जाता है ये नोड, एक नोड ये, एक नोड ये, सो V1 एंड V2, राइट, V1 एंड V2 आर देयर, ठीक है, फर्स्ट node and the second node, right, V1 and V2. So what you can do here is you can directly apply what you can directly write G times V equal to I, G times V equal to I, right? तो आपको कंडक्टेंस मैट्रिक्स फाइंड कर लेना है, ओके, जब भी इस तरह का नेटवर्क दिया रहेगा। कैसे करोगे, देखो, कंडक्टेंस मैट्रिक्स, ओके, ये वोल्टेज वेक्टर आप ले सकते हो, आई एज अ वेक्टर, राइट। सो यहाँ पर आपको देयर आर 2 voltages, so 2 by 2 का मैट्रिक्स बनेगा, दिस इज V1, दिस इज V2, and next you will get is there are 2 sources, you can say that one of the source is going, you can say this is the node if I consider, right, मान लो ये वाला नोड हम कंसीडर करते हैं, ठीक है, ये वाला नोड, so this current is moving away, right, this current is going away, you can say, ठीक है, एंड इसमें कितना है वोल्टेज V1, यू कैन से हियर इट इज V2, ओके। तो ये करंट आपका गोइंग अवे फ्रॉम द नोड, राइट, अंडरस्टूड। So what you can do here is you can say that this will be equal to, you can consider, what you can do here is, it's a very simple circuit, right, it's a very simple circuit, you can directly find out as well, okay. So you can find out the like conductance, so इसका हो जाएगा 1 millisiemen, this will give you you can say 1/2 millisiemen, है ना। You just convert into conductance and you can find out the conductance matrix times the voltage is equal to current, okay। अब आप कैसे लिखोगे ये आपको समझना है, ठीक है, that you have to always keep in mind. So V into conductance will be equal to, you can say this, so this current I'm just going to take 7 milliampere and this is 14 milliampere, so whatever current is, and just we are considering like this, you can, so this is the current which is going into, now you can find out the conductance here, right, so conductance 1/2 plus 1, that is going to be giving you 3/2 millisiemen, okay, and this conductance you can take it like 1 millisiemen, okay, and then this again 1 millisiemen, and this plus this, like you just take the 1/4 millisiemen, 1/4 plus that is 5/4, okay, and you just solve this. So this kind of circuit they will ask, and you have to just form the you can say conductance times the voltage is equal to current, okay, so you have to think कैसे होता है ये, ठीक है, एक दो बार करोगे आपसे समझ में आ जाएगा, राइट। सो विल मीट इन द नेक्स्ट सेशन गाइस, दिस वाज ऑल अबाउट बेसिक्स, और in the next session I'm just going to talk about you know uh, nodal analysis with independent voltage sources, okay, Suppose there will be independent voltage source and how to apply the nodal analysis. मतलब दो नोड के बीच में अगर इंडिपेंडेंट सोर्सेस प्रेजेंट हैं तो ठीक है, ओके। अगर मान लो दो नोड हैं, उनके बीच में इंडिपेंडेंट सोर्स प्रेजेंट है, हाउ टू अप्लाई द कॉन्सेप्ट, राइट? सो दैट इज कॉल्ड एज सुपर नोड कॉन्सेप्ट, राइट? सुपर नोड, okay. This is one type of problem that you might expect in your gate exam, okay. And super node for nodal analysis with independent voltage source, that will be our headlines, okay, for next session event, ठीक है। And the next after that what we will talk about, that is very very important concept, ठीक है। Then we'll talk about nodal analysis with some dependent sources, okay. So some dependent sources will be present and how to apply the node with dependent source, okay? That is also very important. तो ये सारी चीजें हमें डिस्कस करना है। फिर क्या करेंगे, नोडल एनालिसिस विथ dependent source means there can be different kind of dependent current source, I mean dependent voltage source, और it can be dependent current source, okay. फिर हम लोग प्लेनर सर्किट की बात करेंगे। प्लेनर सर्किट होता क्या है? प्लेनर सर्किट डिस्कस करने का केवल एक ही बेनिफिट है कि we will start talking about mesh analysis. So for discussing mesh analysis, you need to have the concept of planar circuit. अगर आपको प्लेनर सर्किट का आइडिया रहेगा, then you can talk about mesh analysis, right? ये प्लेनर सर्किट होता क्या है, that we have to understand, right? प्लेनर सर्किट, then we'll talk about mesh analysis and then we'll conclude and we will see that which one is good, right? Whether node analysis is good or mesh analysis is good, it depends upon you, right? मतलब आपको जो questions आएंगे, they are very specific question they are going to ask, okay? तो आपको ये रेडी रहना है, कोई भी टाइप का क्वेश्चन आए आप सॉल्व कर सकते हो, ओके। फिर मेश एनालिसिस विल टॉक अबाउट टॉक विथ इंडिपेंडेंट सोर्सेस आल्सो, कैसे केवीएल लगाते हैं, बट आई विल नॉट सजेस्ट कि ज़्यादा टफ कॉम्प्लिकेटेड नेटवर्क नहीं आएगा आपके एग्जाम में, बट आपको आना चाहिए सारी चीज़ें, ठीक है। और फिर सुपरपोजिशन थ्योरम, राइट, एंड देन थेवेनिन थ्योरम एंड ऑल विल टॉक, राइट, ठीक है। थैंक यू सो मच फॉर टुडे, विल मीट इन नेक्स्ट सेशन।